Welcome to the session on domain-driven design and REST. My name is Oliver Gierke. I work for a company called Pivotal. Has anyone ever heard of Pivotal? Oh, anyone ever heard of Spring Framework? Okay, that's a bit better. Yeah, we're the company behind the Spring Framework. I'm part of the Spring engineering team, taking care of the Spring Data projects in their entirety, basically, and I'm the project lead of that. And you could ask, why is a guy who's like only working with data, basically, talking about DDD and REST? And the reason for that is that I'm involved into like two major aspects of the Spring Data space, which is the Spring Data store implementations that on their very upper layer expose a repositories programming model, which gets us the connection to domain-driven design. And on the other hand, I've coined a tiny library called Spring HDOS, which basically brings support to create hypermedia-based representations to the Spring MVC framework. And on combining these two worlds, I've also authored the Spring Data REST module, which is basically taking your Spring Data repositories and turns them into a foundation for what could be a REST API, right? And if you look at that slide here, you could basically think we're taking like data from a database and then flipping the tables by 90 degrees and then turn that into JSON and call it an API. So that's not what we want to do. And actually developing Spring Data REST has taught me quite some lessons about why that's a bad idea and how we could actually do better. And coming from the fact that REST is not CRUD using JSON and HTTP, I asked myself, okay, what's actually needed to take your domain model or your DDD domain model and turn that into a neat REST web service? Or to phrase it the other way around, if you don't do any particular, or if you avoid thinking about certain things in the DDD area, what problems will you get when you build the REST web service, right? So you probably all know this diagram here. It's from Eric Evans' book, Domain-Driven Design. What I'd like to do is concentrate on these aspects in the upper right here, like briefly discuss. I don't want to do an introduction to these concepts because I'm assuming you're here because you already know them. And just take a look at those concepts from the consequences that they usually have in like using these concepts and the consequences that has into when building REST web services and representations in particular, because that's going to be like the main topic here. As you've seen, like if I'm working on a Spring framework, that usually means or mostly means coding in Java. So some of the challenges and stuff might be related to the language actually. And others might be a bit more fortunate here. The first thing, and that's why I mention it here, is value objects. Value objects are a very powerful thing, but they are really a pain in the ass to build in Java, right? So if you just want to build an email address class, like you have constructors and then equals and hash code to implement and all this kind of stuff. So that's actually a reason why people avoid building these or using value objects. The most funny thing I usually see when it comes to like the JSR 303 validation APIs, when you have a class that has a string property that says email address and it has an annotation saying email address, and then I always wonder, okay, why don't you make it a type in the first place? But people are lazy, and that's why they avoid using value objects sometimes. But even if you have to code them manually, I think it still pays off. If you don't believe me in that case, there is this like this talk on value objects by Dan is something like the Conway's law reference. No DDD talk without linking to that talk here. It's like all about value objects and how they basically allow you to control complexity in your code and make code easier to understand. So this is That said, they're still worth it even if you have to like code them manually. However, there's Lombok. Have you heard of Lombok before? So if you like haven't seen that before, have a look at that. It's basically an add value annotation on the class that in this case, and that makes it quite usable and easy to create those types. Still, if you've taken that hurdle, you get other opponents. Now that you have the language out of the way, you face Hibernate and Jackson. And mostly the problem there is that they require you to make stuff, or it's hard to really write immutable types or classes with these frameworks in mind, right? So you have to teach them how to map certain strings, like an email address string from your JSON representation into that class and backend. It's not really hard, I'm not saying that, but it's like cumbersome and takes some efforts here. Still, value objects, important aspect here. So entities and repositories. That's what like most people deal with on a day-to-day basis, even if they have like string fields for email addresses in their classes. But the problem, especially in the Java space, is with there's JPA, in case you're familiar with that one, where sort of everything is an entity, right? So it doesn't, the entity concept in JPA doesn't necessarily match the one in domain-driven design, and that makes it sometimes a bit hard to differentiate one from another. Let me give you an example here. Let's say we have a customer that has an address and some payment information here and an email, right? And there's an invoice pointing to the customer. There's an order that consists of line items, and the line items point to a product, right? This stuff translated into JPA would basically mean that address might probably be an entity. The email, as I said, rather a value object. Customer is probably an entity. Order is an entity. Line item is an entity. Yada yada yada. So the thing is that, like, as I've tried to express here in that model, there's certain clusters of functionality, basically. So everything related to the customers can be slightly grouped here. And the relationship between an order and the customer and an order and the line item is a completely different one, right? I guess you're trying what I'm trying to get to, which is basically that some of these entities form aggregate roots, and by that, aggregates around them, and others don't. And that's something, if you just look at the entities in your application, you don't really, the model or the code doesn't really reveal that, right? That concept. It doesn't reveal what an aggregate root is in your code. Fortunately, a repository is defined to be basically, I mean, it's not defined that way around, but essentially, an entity plus a repository forms an aggregate. Why is that? An aggregate is defined, or the aggregate root in particular, is defined to be the thing that you interact with, that you pull out of the repository, or that you create through a factory. And all of the contained entities are only referred to or used by referring to that aggregate in the first place. That also has the consequence of that, like, the aggregate root or the aggregate has the responsibility to control invariance on that entire aggregate, right? So it makes sure that the aggregate in itself conforms to certain constraints and like business logic, right? So that means if we take the repositories into account, we can basically find all the entities that we have repositories for, and then know that they're aggregates, which is kind of useful information because, as I said, aggregates are like nice, or they create some kind of consistency boundary, and by that fact actually make up nice representation boundaries for your application, for your REST web service. Another thing that plays into this is that aggregates are the things that you usually refer to. So some part of an aggregate, as you've seen in the example before with the order and the order item, the line item, where the line item referred to the product, right? So a nested entity in that aggregate is referring to some other aggregate, and it's only allowed to refer to other aggregates, not to entities within other aggregates. And the interesting or the convenient thing here is that because aggregates are the primary thing that you refer to, you can nicely translate that into the resources you exposed. They are identifiable, and only those things that can be identified you can actually refer to. Right? So you can only create links to these other aggregates. I just came back, like traveling here from a customer workshop, a 2-day customer workshop on like Build Ape. They have this legacy database, and they want to like wrap that with a nice API. And these guys got started with we take Spring Data REST and we generate our JPA entities from the database because the tooling allows you. And then we, for every entity, create a repository. And then we flip on Spring Data REST, and then all of a sudden we have a REST API. And it's like, okay, that's not really what you actually should do because, as I said, the repository turns the entity into an aggregate root, and if you have a very fine-grained table model, then it doesn't really, you don't really create all aggregates on their own, right? So it's a key point to always return to what's your actual conceptual model, and that's what I spent the last 2 days doing, actually reminding them. No, I don't want to know about tables. What does the model look like, right? And that's not an easy thing to do, but it's something you should remind yourself of. Another thing that came up actually in that very workshop is bidirectional relationships are kind of problematic because they basically mean that both sides have to be governed all the time. And I'm not sure this is a Java problem here, but especially in JPA code, I've seen a lot of broken bidirectional relationships that happen to work by accident because they were just manipulated from the right side, but that was just because nobody manipulated it from the wrong side by accident, basically. Okay. That was one thing to mention here. That especially becomes important if you're talking about like what makes up a bounded context, right? Bidirectional relationships between a bounded context are like even a worse version of that thing that you should try to avoid in the first place. All right, so much for the very fundamental things. I don't want to stretch that too long because or the more interesting thing to talk about actually here is domain events. So what does domain events mean? Basically, it's actually the way you express events to the domain, like not technical events, but like business events that happen to that domain, and thinking in those terms. And the first thing that you could do is basically not do it at all. Right, and that's usually code that you see, or if you see a code like this, it usually looks like you have a class that has getters and setters, like domain classes, and people just call setters all the way, and this is the same are the same pieces of software that usually understand REST as CRUD over HTTP, right? So you get some data, you manipulate data, and you write that back, right? It's basically a databases via HTTP. Fine. So the next level that you can get to is basically make the operations to your domain types explicit by exposing methods on those domain types, right? There's this. It's basically that's what I'm trying to boil it down to. If you're calling more than one setter, or if you see a piece of code that calls more than one setter in a row, you're basically missing a concept here, because you're not changing, you're not poking at the thing, but you're doing something to the thing, and that should rather be expressed as a method, right? Classical example is, although it could be just like it's actually just a single setter. If you change the address on some user, it shouldn't be set address, because that doesn't reveal any context. It could be like move or something, right? Depending on your domain, of course, but be expressive there. Whenever I see client or code that calls more than one setter on some object, I rather introduce the method, a more dedicated method on the object, and then change the state internally. So that gives you quite a bit already. The next thing or the next level here is exposing some of these operations on the domain model as events to other interested clients, right? So it's basically you consider these domain events state transitions, which already brings us into the or state transitions as domain events, and then that actually nicely gives us a connection to the REST world here, because that already gives us a hint to what we could do with these explicit state transitions and how we could actually model them in the REST world, right? And an approach you see quite often actually is to export those events into via feeds, right? So like an atom feed with the relevant stuff that other parties might be interested here, and like that can be consumed. You could also use like messaging or something to inform other parties about those events. But as we're talking about REST here, I chose the example of feeds. The reason why I think, or the special reason why I think is probably another level is that it doesn't have to mean that we're talking about event sourcing on level 2, right? Event sourcing is basically, or CQRS, or the combination of the two, basically is taking that to the level of turning everything into events, right? So every operation is expressed as an event. That doesn't necessarily have to be the case on level 2, because in that, if you're operating on that level, you just like decide, okay, which of the events are really needed to be stored and then later like published to other parties. All right, okay, that's we'll get back to level 2 in a few minutes. So I've spoken about like or been covering DDD quite a bit yet, and haven't like made too much connections or too many connections to REST yet. So you probably all know that like the very fundamentals. So we're talking about resources that are identifiable, referable, and they're always communicated with through representations. And we use a uniform interface. But the core thing in terms of designing the API usually is designing the representations. So basically, finding the resources that we want to expose. I'm explicitly saying not modeling URIs. Finding the resources that we want to expose, and then deciding what goes into these resources and what we can do with them. By what we can do with them, I, of course, don't mean like the individual methods to trigger, because that's what REST already defines. But from which state into what other state these resources can be transformed, and how to express that, right? So I already made the point that aggregates are like a kind of neat thing to look at in the first place. So assuming you have your domain model with, let's say, like 5 aggregates or something, because they actually expose certain characteristics like identification, referability, and also quite important, the scope of consistency. Because like changes to an aggregate should be consistent within the aggregate. They make up a nice foundation for a resource, because like if you issue a put request to the resource, and that consistency boundary maps to your domain nicely, then you don't have to think about like explicit transactions or transaction resources or process resources in the first place. I'm not saying that is like is always doable. Like just take the aggregate, turn it into a resource, and will be done with it. But it's at least a good starting point, because resources actually share the same characteristics here, like the resources to be exposed and the APIs. Right. So we got that. The next interesting thing here actually is the topic of hypermedia. So What does hypermedia mean? I'm not coming up with the unpronounceable abbreviation here, but it's basically serving like data that the client is interested in with navigation information, right? So we're not returning just an arbitrary blob of JSON, but we include some means of communicating links, like let's say we use HAL or collection JSON or Siren or whatever hypermedia format you want to use here, HTML. And the client actually uses that information to find out what it can do with the representation. So what that actually means, that shift in the client, is that let's say you just write an iPhone app, and I have an example, a bit of an example project later on that's placing coffee orders. Let's say you have an iPhone client with that actually speaks with that web service, and I place some orders into my cart, and now have to like find out, okay, am I allowed to, or I want to go to the checkout, right? And the interesting question is, how does the client actually determine whether it can actually do that, or should present the button to the user? And the non-hypermedia approach is basically knowing about what the server, when the server will allow us to check out, and code that knowledge into the client, right? So we actually coding domain knowledge into the client. With hypermedia, we basically trade the knowledge about the domain complexity, or we trade the domain knowledge with a little bit more complexity in the protocol, which in my previous example basically means we're not really binding ourselves to some knowledge that's documented somewhere, but we actually just check whether a certain link is present in the representation and act upon the presence or non-presence of links, right? So the client, has anyone been to the previous talk here? Oli, of course. There was the question came up with like, do you actually recommend hypermedia? And the answer was, well, yeah, sort of. People rather like to like just get the JSON and send it back and poke at it and stuff. That's fine, but if you have to like prevent domain knowledge from leaking into the client, then hypermedia is your only option, basically, right? And it actually is very aligned to the notion of domain-driven design, which tries to keep the complexity of a software system in its very core. And in that case, in case of a REST API, that usually means the server, right? Right. So we trade this the protocol complexity, which is of course exposed to the client. So because all of a sudden it has to know about links and hypermedia formats and yada yada yada. We trade that complexity with the preference or the benefit of not leaking domain knowledge to the client, or less domain knowledge in the client, because it's just link present or not. Yeah. So another thing that plays into that is that it's just a general recommendation. I'm again coming from that argument that, okay, we just do like our resource and then we patch it like crazy and we just know which fields we have to update when and yada yada yada. So if you want to prevent that knowledge from leaking into the client, don't like if some client uses a patch method, that's very often something I look at and see, okay, is that really the thing that it should do? Or should it rather like look for a link and then follow that link, and we formally describe as a server, we describe what that link actually does and in which circumstances it actually appears, right? All right, the final thing on that front is that if you're implementing a domain model in code on the server, then you usually are exposed to quite a few technical aspects that like play into the implementation, and it's a good idea to actually make sure that these technical or server-side aspects don't leak into the client, which actually means that you have to take care of turning them into web appropriate ones, because very oftentimes the HTTP or like REST in general has certain means to achieve certain things that you could just map these server-side implementation specific things to. What am I talking about? The first thing is that's basically the rule I wanted or made up in the first place is aggregate routes become resources in the first place, and a common pattern you see, and that's probably a bit of my flavor of the worldview here, because we're dealing with repositories all the time. They very nicely map onto collection and item resources, say /customers and /customers/ID. That's very like on the server side, the client shouldn't care about URIs, as I said, but from the server-side design point of view, that's a very nice match. The relations between or two other aggregates become links in the representation. That's actually what, I don't want to be too implementation specific here, but that's what Spring Data REST basically does, right? It analyzes it finds out about the entities that are managed by repositories, and whenever a domain object refers to another entity that's repository managed, it becomes a link instead of being embedded, and that naturally forms those like aggregate representations and the using hypermedia aspects. I show you an example in a bit. Very important thing: URIs are URIs are URIs, or IDs are IDs are IDs. There's like tons of tickets going are being opened in Spring Data REST that ask for, why is the database identifier not contained in the representation? Because a resource is identified via its URI, as the name suggests. Pretty simple, but the more meta story here is that there are some properties in your code, or some artifacts in your code that actually belong to a very like store specific like implementation or whatnot, and they shouldn't really appear in the representation, right? Because they would actually leak information here. The same goes with the add version properties for those of you not from the Java space. JPA, or the Java Persistence API, has a mechanism of doing optimistic locking, right? The server counts up a version for every save operation, so that when you read an entity, let's say I get customer with the version 1, then someone behind my back updates the customer. That makes version 2 on the server, and I want to update the customer then again with me sending version 1. That would get rejected because, I basically send an outdated version. The thing is, that stuff that shouldn't necessarily make it, or shouldn't actually make it into the representation, because there's an HTTP mean for that, or some way to actually represent that, which is basically e-tags, so that you can use conditional GET requests, or, as I've just outlined the update scenario, conditional put requests, right? So we basically move stuff from the domain object into the appropriate, in this case, HTTP headers here. The same goes with, a last modified property. So there's a means in Spring Data, in this case, to automatically get the last modified property set, and we turn that property into the last modification header. That's basically the sort of the same thing here. All right. So it's 30 minutes. To give you an example of what this might look like in like put into code, I created, or actually a long time ago I created this thing. There's this book from Ian Robinson, Jim Weber, and that guy I'd always failed to pronounce correctly, Savas Parastadidis or something like that. O'Reilly RESTful Web Services, is that one? I always mix them up. REST in Practice. Thank you for that. The other one's good too, so don't want to offend anyone here. The core of that book is, as I said, this Starbucks kind of shopping experience, and modeling the ordering flow of a shop like that in an API. And it has a funny or kind of interesting. It's an interesting example because it's very tiny. It's very easy to look at because everyone can relate to drinking coffee or tea or what have you, and it's very. There's nothing fancy to it, but it contains quite a lot of interesting aspects of a more complex API. It's not just like it's not just CRUD over HTTP, right? So that's kind of state diagram is basically the order flow, right? We place an order, that's state transition 1. While the order is in the state of payment expected, I can update it, which is that part where some sort of CRUD operations are just fine, right? Because it's just basically that very returning to the same state here, and we're just updating or could update, add new drinks to the order or what have you. You could model that through an explicit state transition as well, but in the implementation, I just go with a post or patch request in this case. But then there's like two interesting state transitions. The one is like canceling the order, and one is the paying in this case, which puts the order into a kind of preparing state. Then it's processed in the background basically until it gets into a ready state, and then I explicitly have to acknowledge that I received the order to get it into a completed state. So if you just go ahead and naively model that with, or let's say even you could model it this way, right? Or even like document it this way, which you probably don't want to do because you expose URI patterns here, which is something that you probably don't want to do. And the even more interesting aspect for this scenario here is that there is certain constraints to when you can interact with which resource in which way, right? So you can you're only allowed to trigger the payment if the order is in that particular state, right? And if I take that kind of order or that description of API as a client developer, I basically now have to go ahead and find out what does payment expected actually mean. And then I have to probably inspect the representation for certain fields of certain values and what have you. And all this is stuff that I need to bake into my clients to know when I can actually present the button to eventually issue that REST call here. So if you take it slightly differently and just declare resource types and say, okay, whenever you find a payment link, or relation types in this case, because, whenever you find a payment link, you can just like issue, of course, a put request, and then you have to define the payload that needs to go with it, and then you submit the order, and that actually brings you very much closer to the actual domain here and the implementation of the domain. Meet Spring REST bugs. That's just like there's an implementation based on JAX-RS in the very book. I took the chance to basically see, okay, what would the implementation look like if we build it on the Spring stack, and then was basically going crazy with using like all the Spring technologies that could help me doing that. At its very core, it's basically just like Spring data on the persistence layer, probably as expected, which basically means everything that's white here is we don't write any implementation code. That's just like interfaces. The service layer for the orders management part, that's why I mentioned that before, is we use Spring Data REST on top of the repositories directly, which basically means we get all of the CRUD operations out of the box. But we take the time to manually implement the payment process because that is the core of our API, and we want to use the advanced Hypermedia means for that. So the idea of Spring Data REST is because it takes away the pain of all the standard stuff you want to have, like a post to create a new entity, what have you. We take the pain out of the standard and boring stuff and allow you to basically concentrate on the more advanced stuff, which means modeling your Hypermedia transitions and making it easy to build the stuff. There's a certain shade of green here, which means that we tweak the output of Spring Data REST and basically tell the framework that it should include, under certain circumstances, include certain links, so that these links then point to our manual implementation of the REST web service. I show you the example in a second. Just to summarize a few parts that you should look at if you look at the code. I always try to keep the Jackson customizations, which means JSON customizations to non-Java people, separate from the domain model. It's too easy to just like annotate your domain classes with @JSON, ignore and stuff. You can always externalize that, and that's what I usually try to do, just to not mix the representation-specific parts with my core domain. We use Spring Data for the CRUD parts, that's what I just mentioned. And the other interesting or most interesting aspect for that like discussion between like, okay, what does the domain do and how does it actually play into the design of the REST web service, is the resource processors. That's an API which basically allows you to tell Spring Data REST, whenever you render an order, please call my code beforehand, and then I can actually add some links to the representation whenever I want. The code's on GitHub, of course. Let me show you that thing. It's a Spring Boot app. That's just the best way to build Java apps these days. Probably not surprised to hear that from me. I run this thing first. Yeah, run it. Java application. It ships with a Hell browser. That's the nice thing with that's not something that's something that I actually built here in the POM. That's why I have it open. So no. That's probably just what's going on. There's a how much time do we have? 10 minutes? There's some Java process running somewhere. Tomcat doesn't like if you have a running instance of it and put your MacBook to sleep. Yay, it looks better. All right, so that thing here is that's a good idea. Thanks, Phil. That's called crowd computing. In case you haven't heard of that, localhost 8080. So. All right, Hell browser. Does anyone of you not know what the Hell browser is? A few hands. Okay, it's worth mentioning. Then let me just go back here and say HTTP. Increase that a bit. 8080. So the thing actually exposes a web API that uses the Hell format. That's what Spring Data REST does out of the box. And Hell is a format that just like defines what links look like in JSON. And by the virtue of that, you can build an application, what the Hell browser basically is, that understands these links and presents them in a nicer format than like just looking at raw JSON, which is basically the stuff down here, right? So the Hell browser interprets that format and sees, okay, there's a RESTbox orders link that has a title. So in that case, it's internationalized. It says like see or create orders, basically. Because I'm using a German browser, that's why it's German here. And then you can follow these links by just like clicking these buttons here. That makes it a bit easier to play with your API, and you don't have to pollute your code with bloody Swagger annotations. So. Yeah, that's an individual order here. So we are exposing a collection resource for all orders. I follow the link to orders and get like the two of them. I've created two, and I can just follow that one, the self link here. Nope, that wasn't quite right. Did I break something? No, that was right. Okay, I just got messed up in the UI here. So as you can see, the service exposes certain links. In this case, the payment link, which I could like issue a put request to then, and basically submit my credit card. And if I do that, it basically brings the order into a new state that doesn't actually contain the payment link anymore. I've created a test case for that, which we could briefly, let me just kill that thing and run the test case instead. That actually, and that's kind of neat to see, I guess, we're doing a 4-step thing here. We create the new order, so issue a post request, then trigger the payment, which is done by finding the payment, like we discovered the link with a certain payment. So the test case basically acts as a REST client here. We discovered the payment link, assert that it's been given, and then I post or I put my very secret credit card information to that to that link that I've just found here, the payment link, right? And what I'm then doing, and this is because it's a test case, I basically try to delete the order. So I pay first and then try to cancel it effectively, and then make sure that I just get a method not allowed in this case here. Let me just run this thing real quick for you. Access first order, that's not it. Where was it? Screen resolutions. Run this thing. That's kind of, it probably, Jesus. Let me just bring down the resolution or the font size a bit. What does that actually do? That should still be readable, right? Yeah, even better. So you see we're discovering the payment link here that points to a new order here, and then trigger the payment and start the process in the background, and then poll the server for the result of the order. There's a lot of APIs in here that make that happen, or I mean the order subsystem, basically the left column of the diagram you saw before is basically that. It's just like a few domain classes that of course use Lombok and expose a repository, and the integration for the payment stuff happens through that payment order resource processor. So in case you want to look into this thing, that's probably the interesting part regarding Hypermedia, because we basically get the order before it gets rendered and then add links to the controller, to the payment controller, and you see that's like driven by like state of the order, and if the order is paid, we just like add the payment link and yada yada yada. So yeah, it's a bit of a toolbox that allows you to start with a like neatly defined domain model, expose your aggregates, and then tweak stuff into it and use that domain code to transport stuff into the HTTP representations. Code is here. Any questions? One question in the back? I can repeat it, that's fine.
You mentioned event sources. How does it work with event sourcing? Is there any, like, also maybe like a Spring framework support for that?
Okay.
It's not like just access the database.
Yeah, the question was, okay, what about event sourcing? And event sourcing, how does it works? Right, so that was the thing. The reason I didn't really mention it, because it's definitely worth a talk on its own. The other thing is that it's not really part of DDD, so it's not like it's usually like a consequence of taking the eventing model to the very extreme, but it's not actually part of the core book. I looked it up, so it's kind of interesting. Event sourcing the concept of working with domain events is, but the implementation way of like having a dedicated event store and stuff is not. There's no support in the core Spring framework dedicated to that. There is this Axon framework. Have you heard of that one? It's a Spring-based framework that actually takes the concepts of an event store and provides you with APIs that allows you to like capture domain events, store those, and then easily create a read model from that event store and then use that on read requests. But there's no dedicated integration with that. The thing is that even with event sourcing, you basically come to a point where you have to find out which are the important events that you want to communicate to the client, that it can basically, like the state transition of triggering a payment, right? That's an important event, and you have to communicate that to the client somehow. Whether you implement that on using consuming that event using event sourcing, or just like with plain repositories, doesn't really play into the way you expose your REST web service. So because of that, the level 3, was it level 2 in my leveling model there, to me was the more important one, because if you make certain events, or the most important events that are the most important ones to your client, explicit in your model, it's very easy to put some hypermedia means on top of them to express them to the clients, right? That was the reason I didn't really go that step further. It's just like, doesn't mean I don't think it's worth doing it or something. It's just like, okay, I don't want to overcomplicate the topic here in this case.
Questions on speaker rate.
Yeah.
First one is, when would you use patch instead of put in the DDD environment?
Well, that isn't really a question of DDD in this case, because like put requires you to update the entire resource. The question was for the audience, when would you use patch versus put? Patch is usually used for like partial updates, and there is some media types like JSON patch and JSON merge patch to actually express changes to an object or a document graph. Yeah, the reason I like patch because of its flexibility, but I don't like patch because people tend to overuse it to poke at stuff and like arbitrarily change things, which is basically the opposite of what I try to communicate here.
Okay, so the next one is, do you recommend API versioning?
No, of course. Of course not. Do you recommend API versioning? I think a key aspect of REST is, and doing REST with Hypermedia is actually kind of idiotic, because there's no REST without Hypermedia. But a lot of aspects of REST are giving you, the consequences of doing REST are a lot more flexibility in terms of changing your API, or evolving your API. That's basically what you get from that extra effort of using Hypermedia. And that means you are less likely to run into a situation where you need what people usually consider as versioning an API, right? So like either via media type or URIs or whatever means there are. So you don't want to do that, because you're inevitably breaking clients with that, and that means effort, and that also means effort in maintaining different versions of an API. So if you don't have to, don't do it.
I put a question, but it was more in the direction of, okay, do you see a situation where for domain-driven design can you do versioning? Because it doesn't seem fair to me also. That's why I'm putting the question.
Oh, it's you was the question. Okay, it's for your question. Okay. So what was the point again?
Like in
Like,
that context, when you do, okay, you want to respect the patterns for domain-driven design, it doesn't have anything to do with versioning.
yeah, of course. Yeah, that's a good point. So the DDD patterns don't really discuss the aspect of versioning. Yeah.
So that's a more, please keep it shorter.
Yeah, of course.
Next one is, where do you see the business logic in the example where the API is directly using Spring Data REST?
Can you repeat that?
Where?
It was also mine.
It's yours. Just go
Okay,
ahead.
so you had an example where you expose directly via Spring Data REST to the API,
Yeah.
some resources,
Yeah.
and you map that directly, doing CRUD operations directly to database.
Yeah.
In that example, where
Yeah.
did you see the business logic?
Oh, the question is where does business logic go if you use Spring Data REST? Because it basically takes post operations to create stuff, and it supports like delete if you have a delete on your repository and whatnot. So there are basically events that Spring Data REST fires. So whenever a resource is about to be created, you get the resource before it actually gets handed to the repository. So you can sneak in or plug in some validation logic there, of course, which is something that's usually always in there. It respects security, Spring security annotations out of the box. But so there's the events are the primary means to like plug in just like Java-based business logic. What you can also do is just like selectively override resources, right? So you could just like plug in your own Spring MVC controller and say, oh, by the way, I want to handle put requests for orders myself, and then just do what the heck you want at that point.
That is true as long as you have a very low granularity API. So example, for back office applications, but there are situations, for example, where you only expose some business. Okay.
Let's have that
I
offline.
think it's a longer discussion.
Yeah.
Is it dangerous to expose the IDs from the database directly to the client?
Strict answer: yes, it is. I wouldn't want it, and I think I had it in the talk. In the REST world, the things that you know about are URIs, and as the name suggests, unique resource identifier. These are the things that you should identify your resources with. Everything else needs to be like done using like query resources or something. So you find something by something, and that's much more effort because you basically have to know about the URI template, have to expand the URI template. You have to know to which property to put in there. So of course you can go ahead and expose a URI template that just takes a database identifier and then looks up a resource instance from that. But that basically means that the client knows about that thing being an identifier, that part of the object being identifier, or that property. And if that's not the case, I'd just like to not tell the client. That's basically it. If URIs are sufficient, and they should be usually. All right.
Yeah, there are a couple more. I mean, I don't know if you're still patient.
Okay, I can. I mean, gotta catch the train, but
Yeah.
we still have time.
Let's go on until you say stop.
Okay.
What if you want to return only a subset of fields of an aggregate say prices?
Interesting question. So how do you actually limit your scope of properties? You can always use like just in this case the Jackson customization. So you can add JSON ignore fields. There's a dedicated concept we have in the framework for projections. So you can on the server side define an interface with only the properties you want to expose in a certain case. And even enrich that with like calls to other Spring Beans to enrich your representation if you want to. So the other way around works well as too. And then the client can actually ask for that particular projection, as we call it. So you can have a customer excerpt and stuff like that. But that's probably like taking too long to explain in detail. There are means to it, and it's something that we tackle explicitly. So there are SPIs for that.
Two more.
That's
First one
fine.
is why use Hypermedia instead of flags inside some kind of envelope representation? Doesn't it do the same logic on the client side?
Instead of flags in an envelope representation. Are we back to SOAP? Are we back to SOAP now? Is it your question?
I just mean like why you have the actual links where it does the same logic on the client where it's if the link exists through this,
Yeah.
having like an envelope around the representation of the object which says that it's at this state. So payment.
That's maybe. I mean, yeah. I haven't shown you the representation. Actually, there is additional information. There is still a field that says status in the representation, status payment expected. The thing is, I don't want the client to know that this is that's stuff for him to display, for it to display, but not to like decide when to do what, right? So if it's very clear that the links are the things that decide what to do with, that's a lot less information, because then I can change the status field to something else or what have you. If it doesn't like build on that property to decide when it displays which button. Yeah.
Okay, so last one is you mentioned Swagger annotation. So what's your opinion
Yeah.
on API documentation?
My API. That's anyone.
Very extensive question.
Yeah, it's very. Yeah, I don't think Swagger is a good idea, to phrase it politely. The reason for that being that, I mean, Hypermedia is not a topic for Swagger. There was a ticket to add support for that. They outright rejected it. So that's the one side of the story. The other aspect is, if you've ever done or done Swagger documentation and used the annotations in your code, it's getting annotation hell really quickly, and I've seen a couple of examples where they spend like 10 lines of code annotating which status codes could be returned, and like from the method, and then within that very method, they returned a different status code. So it basically suffers from the Java doc problematic, basically the annotations getting out of sync. With what's actually returned. The solution to that is, I think, actually writing test cases for your RESTful Web API and using the test cases to basically document what the test does, right? Because that's what you do to your API and what's proven to work, because otherwise the build would break. Guess what? There's a Spring project for that, Spring REST docs. It's a very young one, admittedly, but it does exactly that. So you could use, and that's actually what the author of the project, Andy, is currently working on, taking that Spring REST docs thing and just manipulating the test slightly to produce some documentation output. It will produce ASCII doctor by default and can then be included into some manually written ASCII doctor documentation. Spring REST docs. That's the link that I want to give you. So thanks for your attention and have fun at the conference.